A little bit more material on sequences. This section starts off with some definitions, such as what we mean by the symbol AN, and more than that, what do we mean by convergent, divergent, and bounded. Some more sequences. So the idea of a sequence is a list of numbers where there's some rule that tells you which number is at a certain position. And some well-known sequences are arithmetic, geometric, oscillating, and sine n over n. Now let's look at arithmetic. Let's set A to say, let's say A is 4, and the common difference, what we add each time, is 3. And this value in the graph is what this value is for these terms here. And as we see, the value of the sequence of numbers is increasing. It doesn't matter what the initial value A is, it can be negative down here. But if we add a positive number, subsequent numbers in the sequence are increasing. And then explore this as to what happens if the initial term is, say, positive, but the common difference is negative. And try and explain why the values of AN are like that. Similarly, for geometric series, changing the value of A and changing the value of R. What happens to the value of AN for different values of A and R? Of an oscillating sequence of numbers where we start with, say, some value A and multiply it by -1 to the n. And finally, sine n over n as n increases. N increases over to the right. What's happening to the value of sine n over n as n increases? Now, what do we mean by a bounded sequence? What does it mean for it to converge? And then going back to a geometric sequence, sometimes it diverges and sometimes it converges. What's the condition for a geometric sequence to converge? And then another common mistake is the sequence -1 over n is bounded, so it must converge. Try and explain why that is false.